Thank you and hi. Usually I love seeing people's faces, so I imagine that you're there, and I'll be glad to take any questions that you have. So please, if there are any questions during the sessions, we'll try to take them on, and if we can't handle it during the session, we'll do it later in the special chat. Okay, great. Okay, so the topic of this conversation is kind of an open source serverless query engine that I've developed in my time at my previous company. The name is Funnel Rocket, but I think maybe the real question and maybe the real motivation for this presentation is like, do we really need another serverless query engine? And how does one, or let me frame it like this, paraphrasing from Futurama, how did I get to this point in life where I say, okay, I'll just write my own. If you're a veteran developer or anything with engineering, and you come to this conclusion, it needs some explanation. So I'll try to share some of the background, and I'll be happy to take questions. And the whole underlying concept is, there's no silver bullet. There's no just one right thing. But at certain points, you realize what your needs are, and then you may want to go on a path that, go your own path. So that does happen, and I'll try to share my experience. Okay, so just a bit of self-introduction without selling myself or my employers too much. So I've been working professionally since about 97, so I'm officially a boomer, I guess. That's what my daughters told me. And I've been really all around the stack. So front end, back end, full stack, all that is really interesting to me. And I'm trying to maintain that same passion for all things software development. I work in Stackbit, which is a small startup that does a website builder for developers. But I only joined there a few months ago. And before that, just when coronavirus started hitting, I was still working at Dynamic Yield, where I worked for several years. And that's where I developed Funnel Rocket, which is this query engine. An interesting curiosity about Dynamic Yield, it's been acquired by McDonald's. So that doesn't happen every day. But I think for context, for this conversation, it does do a service to talk about, just to understand what the problem is or what the problem domain is. So Dynamic Yield, if you look at the marketing pitch, they'll say, okay, we're a SaaS provider of personalization, meaning A/B testing, recommendations, targeting, audience segmentation. And what it really means, like in terms of what we actually do, is we work with a lot of high volume websites. We track the visitor journey. We analyze it, we segment it, and I put it in bold because it's really related to the problem that we're trying to solve here. And once we know, more about these distinct user groups, we can apply any number of optimizations. So it's really like a white hat operation, I should say. Like, we're not buying or selling user data or any of that sort. We're just working for a specific customer at a time and trying to optimize the website better for whatever user segments are there. So in terms of, like, let's say the large customers, because there's always a mix, like each one of these large customers can have millions of monthly unique users, maybe like dozens of millions, and then 100 million or maybe much more monthly events. And when I talk about events, most of our customers are like e-commerce stores. So it means like page views, and then e-commerce relevant events like add to cart, some product or purchase a product, and so on. And the word users is important because we're not just looking at specific events, we're trying to understand users. So we want to understand the real user journey per customer. And that's a big part of the problem. And we'll get into the problem, in stages. Just a bit more about the context of, so I call it like, it's like the king and I. And of course, there's the rise of open source big data and kind of my perspective in it. And these are the years, like the 8 years I spent at Dynamic Yield, were really like following this trend. So when I started there, like 2013, Hadoop was still a thing. Like, and I beg you to a reminder that it all started with Google every time they released like a white paper. So there was MapReduce and Google File System, and then Bigtable, and everything kind of evolved into an Apache project. So Hadoop was still a thing, and then people understood like Hadoop is kind of low level, it's slow, it's inefficient. It doesn't really give you any of the nice functional constructs that when Spark came, that was as close as to a silver bullet in the big data space, as I recall. So Spark was a big thing, and then of course the Parquet file format came along for analytics. And by the way, it also comes, so Parquet and BigQuery and all these things are all coming from this other Google white paper, which you may or may not know, called Google Dremel. So Dremel is a power tool. And if you're looking at the history of big data, it all started right with MapReduce and Batch and all these things. And then people realized, hey, we want things that are more interactive. We want to have these big data sets. And without a lot of pre-baking and ETL, we want to start doing queries. And potentially, ideally, if we can, SQL queries over big data where it rests. So the first attempt, I would say, maybe at this was Google Dremel, which then became also a service to the public called BigQuery. So this all started from this problem. And I think the first stage was like, if you look at BigQuery of how it does things that are really, really similar to Parquet, but it still has this ETL. And then Amazon's Athena came along and they said like, hey, the data is in S3, it's at rest, you're using common file formats, and we're just aiming our little army of query workers at your data at rest. And this was a big improvement. Like all these ETL steps, they are a pain if you've spent any time around them. And of course, the cloud. So the cloud became cheaper and faster, of course, but also something that people don't sometimes appreciate as much as they should, I guess, is better networking. And the reason is not just it's cheaper and faster, but also some architectures that were not possible when the networking was mediocre, as it was in AWS at the time, are now possible. So a large part of what I'm doing would not have been possible if you couldn't decouple compute from storage, because any kind of decoupled solution needs a very fast network, otherwise it's not feasible. So this is a very big step forward, and I'm so glad that AWS also picked up the ball, and the networking now is so much better than it was before. So really, if you look at the cloud now, you have this wide range of options. Like I'm mostly proficient with AWS, so that's where I tested and developed things, but I always try to avoid locking. So if I'm looking at AWS today, you have anything from almost bare metal to completely serverless. So it's really a spectrum, and you decide, the more you need to manage yourself, the lower the cost is. So if you're, at one end, you have virtual machines, and then you have Fargate and all these managed services. And then at the far end, you get to serverless. Like it's the fastest options to get compute and the least you should think about to get there, but also the highest CPU per second cost, I might say. But there's another angle to this, which is that the level of granularity of the billing program is always improving. So it kind of tilts the scale. And what I mean is, if I can do something with serverless and I pay a lot per second, but I'm just paying for the actual milliseconds where I need it up, it can still be much more cost effective than even if I have spot instances, but they're lying around and most of the time they're not doing anything. So if I can use serverless at a high cost per second, but I'm just using it for the exact moments, the exact milliseconds where I need to do something, it might be much more cost effective than all these big clusters lying around, whether they're reserved or on demand or even spot instances. So that's another consideration. And I would say I was with all these silver bullets, and this has been a great, great advancement in less than a decade maybe, but I would say there are a lot of things with big data that still suck. I have no other word for it. Like shuffles is the bane of big data, and complexity of the clusters and so on is still bad. And life in general in big data is pretty hard, at least when you think about auto-scaling and cost optimization. It's a really hard problem. And I can talk for hours on why, but if you want to know more, talk about it, we can do it later in the Q&A. I think this is a problem that's been interesting for me for years. So So let's talk about the actual problem at hand, because we're talking about funnel rocket, not just any specific gripes that I had with big data, even though they're very interesting. So what's the problem? And the problem is, I was kind of thinking about it. So there are many people in the world, right? And this is a problem. I'll explain why, but I think in general it's a problem. And people know it's a problem, that there are many of them, and yet they persist. But let's talk about why is this a problem. So it's only a problem of scale, of course. I'm kidding. And let's think about this, the problem that I was tasked with solving. So a product manager at the time, we started talking about this functionality of how do we explore user audiences. So we have all this data that's flowing in. It's siloed per customer. And a business user or a marketer or whatever you call this role is going into a web UI, and they're trying to understand the user audiences. So they need to do these queries that really can shine a light on the specific journeys and traits of specific user groups. So they can say something like, hey, I want to see users who did this less than 5 times in a week, and then they did something else, and they didn't finish by doing something else that we would hope they would do. So this is a kind of a funnel query or a sequence query. And over this kind of like a funnel query, you also want to apply a lot of aggregated analytics, which is another layer of complexity, because if you actually look at the details, like doing sequences and funnels with classic databases is a big problem. It's usually very awkward to do it if possible, and then it crashes at scale. And then applying all these aggregations and all these breakdowns, like by country and by region and by device and by whatever else you want, and having a bunch of them, this is really a performance killer. And also, when people talk about solutions, and I'll mention ClickHouse at the end, like ClickHouse, for example, like any other technology, it excels at certain things, and it's harder to do other things. So you can do sequences fast, but when you start to do all these aggregations based on the results, it gets slow. So they're always, like in the real world, you always get into these walls. So sequences are hard, and sometimes you see systems where they have funnels and they have sequences, and it's all like baked in. So you do it, and tomorrow you come and you see like the results for that day or the results for the last week. But here we're talking about users who are exploring. So it's ad hoc queries. It's an interactive feature for end users, meaning it's not like I don't know, some BI analyst in my own company, and they can wait 5 or 10 or 15 or sometimes 20 seconds, and they know it's fine. Like if you use Amazon Athena, it's basically an internal tool. So if you have to wait, and even if sometimes it fails or whatever, okay, it's a great tool, but it's for internal purposes. If I want to make something available to my users, I need to make sure the SLA is really, really there. So we want it flexible with all kinds of conditions and ad hoc rules. We want it cheap, of course, and we want it fast. Go and build it. And of course, I'm oversimplifying because the PM was great, and she didn't actually leave it at that. We worked a lot of the functionality, but that's basically the mission statement as it was. And I know I'm playing with the fonts. I think it's quirky, but so here's my thought process. So if I'm looking at this problem of sequences and funnels, so we're talking about users, right? And each user, they have their own history, could be short, could be long, of events. So like all the questions that I'm applying at the user level, I'm like doing something akin to like group by user ID or whatever it's called, and then start asking questions. And the problem is group by works really well, even on a lot of data when you have 10 groups, 1,000 groups, maybe 10,000 groups. But what if you have 20 millions? And within each of these 20 million groups, now I say, okay, find the user who did X, like find groups where X happened, and then find groups where X happened, and then Y happened following that. And with every group, these timings are different. So it needs to have this order in each and every group. And this is a hard problem that usually databases, and I'm talking about Postgres and even Presto and other databases that I've looked at, they're just not optimized. They're great products, and I'm not saying like I invented the wheel, but there are some certain problems that you see, and they are not these fringe problems, but they're still not important enough for the mainstream databases to do them well. So we have this very high cardinality group bind problem, and sequences are making it harder, and then we have to apply a bunch of aggregations. And something I should say is another thing which complicated life for us at least, was that if you look at ClickHouse and many of these solutions, the assumption is you're just pushing more and newer data in. So data comes in, and you maybe apply some transformations, and you append it. And you're not updating anything that came before, because that's much, much, much less efficient. But for us, because we're tracking users, sometimes or every day we discover that user X and user Y are actually the same person from multiple devices, and they logged in from multiple devices. So in terms of optimizing the experience for them, we need to treat them as one. So we basically, I don't want to say like 1984, but we're going back and we're fixing the history. So it's not even just an append-only problem for us. Some problems are like that, and it means you can use more tooling, but if you're using tooling that kind of has this basic assumption of append only, and then you have to start fixing things, it's a big pain. And of course, there's always the option to spend more money on the problem until it blows up. But at some point, it's not reasonable, and the eye of Sauron is on you. And I mean like the CFO or the CEO, and they're like, what's going on here? And then you start making excuses, and you don't want to make excuses, right? So what was our initial approach, which worked nice for a while, for a bunch of years. So nobody wants to reinvent the wheel, right? It's wrong, it's bad, and so on. So we tried not to reinvent the wheel, but I'm gonna make a claim that when you say you're not reinventing the wheel, sometimes you have to customize it so much that you end up inventing a wheel or another wheel based on a common platform. So it's not just about are you reinventing or are you reinventing the wheel or not, but really how much if you have a custom problem to solve. So we started using Elasticsearch, which was pretty good already at the time, and we modeled each user as a document. So now all the data within a user is now in a single document, which makes it much easier to search for a lot of things that need to happen within a specific user or specific document. And we use Spark to take the raw data and index it to Elasticsearch. There's a nice connector for it, meaning you use Spark workers to make this distributed indexing. And there's always a cost, like there's always a price for everything. So Elasticsearch could be really, really fast when you search things if you do it right. But the really, really high cost is the indexing. Indexing is a really, really expensive operation in terms of time, resources, money, all these metrics. So you only shift the problems and create problems somewhere else. And it sounds really cool, like with a lot of solutions, like you start out and you have this X amount of data and it works out great and it's cheap, but then you realize, oh, but I can't really do the sequences the way they should be unless I write a custom plugin to Elasticsearch and I apply some weird data encoding to make the data more optimized, more compact, more friendly for my plugins. And you start going into these rabbit holes over the years, and it's a gradual process. Like you're like this frog in boiling water. So at first it's all cool, and then the heat goes up and up and up until it's like becomes unbearable, and it gets hard and it gets expensive and even slow, and the CEO is unhappy. And to quote from maybe Austin Powers, when the CEO is unhappy, people die, or at least it's a big bummer. And when you think about one other problem that people don't often talk about is this coupling. So of course, there's an Elasticsearch connector for Spark, but what it really means is that you're slowing down Spark. When two online systems talk to each other, and one is much, much slower than the other, you shift the problem and you pay a lot for Spark, basically just sitting there and saying, hey, can I send the next batch over now? Is it okay? And you pay for this time. well, Spark is not doing, because the scale of these systems is really, really different. So any kind of talk at scale between two systems, you have to think about decoupling. And then decoupling is a separate process, right? So it adds this complexity also. So it is a problem. And that's at some point, and of course I'm paraphrasing from Game of Thrones here, I realized that, all clusters must serve, but at some point they must die. And it's the same kind of connotation as it is with Game of Thrones. Must die, it means that it inherently is going to happen. So this is something that we have to accept, like these long hours, these nights, this complexity, it's just in the nature of clusters. And when I say clusters, I mean real-time and streaming and message queue and batch processing and all of them. Like I did it all, I've done them all, and they all have this complexity and they all die at the end and in the most unfortunate hours at times. So can we do something else? And one of the things that I do, and I learned over the years how to do it better, is when we look at the problem, forget about all the solutions and all the cool tech that the young developers want to try, and try to really crystallize what are the traits that we want to have, like what's really important for us. And then the solutions, they kind of present themselves from these basic ideas, but you have to forget about everything that you know about solutions and just think about the problems and think about what are the good things that you want to have in your solution and how critical are they for you, because they're always going to be compromised. So we don't want to reinvent the wheel, but again, we don't want to reinvent too much. We want to rely on existing technology, but it's going to be some work to bring it all together. And we want to have low maintenance, because all these long nights, and it takes a toll on people. And we want it to be fast, and we want it to be decoupled. We talked about, like, Spark is doing its preparation job, and then it doesn't have to do or wait for someone else, okay? And it doesn't have to be Spark, it can be other things. And we want to have a good visibility on costs, and if I can use the same solution for both ad hoc queries and batch, that's great. If I can't, it's a bummer. I want to have minimal pre-dating of data, like as close to raw data as I can, and low overhead. And when I say low overhead, it also means, like, if I'm creating a Spark cluster now, there's so much time, meaning money and time, that is spent on just getting the cluster ready to do anything. And for me, this is pure overhead. Like, and you might say, okay, it's a big tool, it has all this functionality, but in the end, I'm paying for a lot of setup that I'm probably not going to use. Like, I just want to spend time and cost on the actual problem that I have at hand. I want to get nearer to that point. So here's my thought process. We want to go back to raw data. Let's go with Parquet. We don't want any kind of ETL. And we want to do data crunching, sequences and funnels and aggregation. So basically, there's something which is already great, and it's called Pandas. And then it connects to Parquet really well with this project, Apache Arrow. And by the way, Pandas and Apache Arrow are by the same great guy, Wes McKinney, who really should be ought to thank every week. Not even doing it for any kind of profit. And then, okay, I all these tools that I know how to run things at a single task level. How can I run like thousands of them concurrently? And we said, like, no servers, no clusters, minimal orchestration. So maybe serverless. Can it work with serverless? Like, how I'm going to orchestrate all these things? Will it be fast enough? Will it be cost effective? Will it be tied or locked into a specific vendor? So that's pretty much where I got to think about AWS Lambda as a solution. And when I was skeptical at the beginning, but I'll tell you, honestly, I was impressed at how good a solution, how mature a solution it is today. And maybe it's not surprising. AWS had years to work on this. And it has all these features that are really, really good for us. So it can do, you can invoke Lambda synchronously, meaning you can just launch, 10,000 of them, and it will queue them up, but queuing them up doesn't mean it gets slow. Like, it will handle them as fast as it possibly can, But then if you have like any kind of concurrency limits and so on, you won't be just hitting the wall. Like it's like fire and forget, but it runs really, really fast and things don't, it works. Things don't break for no apparent reason. So the default concurrency is pretty good, like 1,000 concurrent, and you can extend it, and you can ask for a quota increase, and the billing becomes better. We talked about how billing affects things, because when I have millisecond billing, I think less about, hey, this takes a second 0.1, so that sucks. Now I have to pay for 2 seconds. No, it's I'm just paying for the work done. And extending the limits, like in terms of RAM, in terms of CPU, I'm not really constrained in what I can do, but still sometimes if I'm doing something that should be really distributed, I should keep it at like one worker is one CPU. Let's keep it simple. So the limits are actually much higher than what we probably need. And it runs Python great. And of course, there always is this cold start and warm start, but I realized like things stay warm. So generally, if you're just using them over time, it stays warm really nicely, and it just works. So there's a lot to it, and that's the point, like going back to the meme at the start of the conversation, that's kind of like, that was the point where like, okay, I'm just gonna write my own with lambdas and pandas. And then I realized, like, then I had this downer moment, okay, but still like orchestration is hard, like doing clusters is hard. I mean, it seems like a big task, like maybe I like underestimated it completely. And then I don't want to have lock-in, and I want to make it agnostic. How do I achieve all of this? And the truth is, and this is where I employed a kind of solution that I bring from time to time, and it's not exactly what you'd expect. But this hero that I'm talking of is actually Redis. And it might be surprising because Redis is, okay, it's a database, it's for caching, it's for whatever, but how does it help us? So one thing that I realized over time, and then I use this pattern over and over, is this Redis is a great tool for actually doing orchestration on the chip, because it has all these constructs that make it so easy to do this kind of like distributed orchestration. So of course it does metadata and caching, of course, it does atomic counters. So if you have to count retries and so on, you have these guarantees of atomicity, which are really important if you have a distributed system. So Redis is really popular for queue systems, like when there's a Redis list which acts like a queue, and then workers come in and they take work in their own, you know, in their own pace, and it has sets, meaning if, unlike a list, if I'm a worker and I have a slice or a Parquet file cached and I see there's work for it, I can try to grab that specific work. And this is an optimization that I actually put inside Funnel Rocket. And Redis just makes it so easier because it's this kind of removal is atomic and it's guaranteed. So you don't have to work as hard on all these orchestration needs. And it just works. It really is simple to set up. It's quite cheap. There's a lot of managed options, and it's it just, you know, I don't have a lot of bad things to say about it. It's like this monosodium glutamate that over everything in your system. So we have all the ingredients. We talked about lambdas, pandas, Parquet, Redis. What's the order of events? And I'm getting to, you know, how it actually works. So we're letting Spark still create data sets of n Parquet files, and we're saving them in cloud storage. So that's the end. I mean, in terms of what Spark is doing, it just puts the stuff in cloud storage, which is really fast, and tells the Funnel Rocket API, I have this API service, hey, here is this data set that exists, and it gets registered in Redis. So this is the preparation step. And when I need to query, any customer query done in our web UI becomes a JSON format query, and an API server, the same API server is called to now run this query. And what the API server does is it invokes a whole bunch of Lambda functions asynchronously, and all the communication, like the retries, the results, the status of things, everything goes through Redis. And this process is really, you know, the project is open source. So I encourage you to look and see. It's it's not that hard to create orchestration nowadays, but it's not because I'm super smart. It's because you have to be moderately smart, but mostly you're standing on the shoulders of giants, and I cannot overestimate how much work has been done to make it easier for us. So really, I mean, I was amazed by how well it worked. And again, not because my code is so awesome or doing things that are so complex or novel, but just gluing things in the right way over this construct that we have can be immensely powerful. So when we think about reinventing the wheel, I'm not reinventing the wheel. I'm just gluing the parts in a different way, and I'm getting a really powerful solution. And this is just in terms of like to tie it up. This is the diagram of, on one end, you have data preparations coming in from Spark into Parquet format in cloud storage. We register the data sets via the API server, and the analyst, or any kind of the end user, when they run queries, it becomes a JSON query, it gets to hit the same API server. And something that I didn't mention is serverless is just one option to run it. I really tried to make it agnostic. So if you want to launch 1,000 containers on Spot instances and do some kind of batch queries at scale during the night, it's also an option, because the idea is to make everything agnostic. And the biggest piece that makes it agnostic is that all the communication flows through Redis. So you really don't care who you're talking to, like back and forth. I think we're pretty much almost out of time here. I just want to say, of course, there's a lot of syntax, which is interesting in its own. I don't want to get into it. You can define funnels. You can define very complex conditions at the user level. And just to top it off, it's an open source project. There's a guide showing you how to download an open data set that is public from Kaggle, and then teaches you, like, in phases, how to apply queries, how to prepare the data, how to do funnels, how to do aggregations. So I don't need to spend a lot of time on that. And really the crux of my conversation, I think, wasn't, hey, this tool does things in specifically X or Y, but how do you get to this place where you develop your own query engine? And how feasible is it? And what tools do we have at our disposal? This is actually what I wanted to convey above all. And I think with that, I do have some numbers here. I can maybe share the presentation later. I'm not sure. There are some interesting numbers. I'll kind of skip them. And yeah, that's the end of the presentation, at least. And I urge you to, if you're interested, I have 2 blog posts on Medium. You can check them out and read about the context, why all clusters must die, and what is funnel rocket. And it goes more in depth. So that's it. And I guess I'll see you all in the special chat. If you have any questions, I'll see you there in a few moments.